G'day guys, it's MiracleMAX. Almost 4 years ago, this channel was born to provide educational videos for you, the viewer. But unfortunately, due to circumstances, I can't guarantee a video every fortnight. But don't panic. I'll still provide quality educational content for you, the viewer. But for now, sit back and enjoy video number 100. G'day guys, you're back with MiracleMAX. What's in the workshop today, hiding its head in shame? It's a Ford Focus diesel? What were Ford thinking? What was the customer thinking buying it? Despite my intense love of the Ford, this vehicle is in the workshop because it has a check engine light on. What's the fault with it? Let's have a look at it. The customer took this vehicle to another workshop to have a look at it, but didn't like the diagnosis that they provided. He then brought it into me to have a look at it. It's quite possible that the other workshop diagnosed it correctly, it's just the customer didn't like what he heard. Let's have a look at it and see if we can figure out what's wrong with it. Every technician's favourite light is stuck on the dash there. That's right, it's the $ in the shape of an engine. Obviously there's a fault code there somewhere, so let's pull out the G-scan, find out what the issue is. Do they have a specific fault code for just being a Ford? I've just done a search for this fault code F0RD fault code, and this is what it's come up with. So if I change the badge on the front, the one on the back, and pretty much everything in between, that should sort out our issue. Sorry Ford lovers, don't hate me too much. But seriously folks, okay, so here we go. Here are the present ones. It's a P2463 and a P242F, both with regard to soot and ash accumulation in the DPF. Now the other day when the customer brought it in, I took a photo of some other fault codes that were present. They included a P0299, which is a turbocharger underboost, and of course those other ones there with regard to a diesel particulate filter restriction, differential pressure sensor, all those sort of things. So let's just start with the turbo one, because in actual fact the turbo can affect the DPF. Let's have a look at that first. Just because the customer didn't like what he was told at the other workshop doesn't mean that they were wrong. In actual fact, this intake hose, our intercooler hose going into our inlet manifold, has got a big split in it. He put some electrical tape around it and then drove to Sydney and then couldn't understand why the light came on. I've put some proper fabric duct tape on there, just for diagnostic purposes only, but this will need to be replaced. I'll pull the tape off now just so you can see what the problem is. But before I do that, I might just hook up the smoke machine and see if there's any air leaks anywhere that might be an indication of a lack of turbo boost as well. Can't hurt, can it? So I'm using the patent-pended MiracleMAX paint tin smoke machine. Perhaps I should make the title a bit shorter. I've got regulated pressure of about 10 psi coming into my air line, which goes into my paint tin, which has baby oil in there that's heated with a resisted wire, comes out the top and is fed into my intake system. Now I'm not worried about, it's not a perfect seal here, so don't panic about it if you see smoke coming off there, but I'm interested if it goes anywhere else. Alright, so for now this tape is holding. But of course that's not the answer. The customer wanted to leave it at that, but I said no, not going to happen. We have to do it properly, otherwise we're going to end up with issues. Even if we do a full regeneration again, it's still going to leak again, isn't it? It's going to split sooner or later. So I'll just keep the air up and have a good look around to see if there's any smoke anywhere apart from our leaks that we have through our intake system because I haven't sealed it properly. But look, hey, it doesn't look too bad to be quite honest. So I might pull this off now just so you can see the split first. When the customer brought the vehicle in, he claimed that it was possible that the other company actually cut this hose with a knife. And oh, look, I can understand what he's saying. You've got a straight line down here and it's actually fractured, as you can see. Now just keep in mind this is an intercooler hose. When under pressure, it will expand more and more and more, and that's why I put pressure in the smoke machine to try and get it to leak, which it didn't. But this is it was taped up at the time, of course, with reinforced tape. But yeah, this is knackered for sure. But look, hey, any sort of hose, you give it long enough, it's going to fracture. I don't think it's been cut with a knife. I think it's just fractured. I don't think the little Ford liked what I said about it before. It drew blood. I'm glad mechanics don't have like blood rule, we'd never get any work done, hey? So to gain access to this intercooler hose, I've actually removed the headlight. And yeah, it's a bit of a pig to get to, but when I put it back in, I'll face the clamp a different way just to make access a little easier. It's tucked away and it's put all the way down the bottom there, and you can see which way the clamp is facing. So I just ended up using a little tiny quarter drive ratchet to access it, but when I put it back in, I'll put the clamp in a more accessible area so I can just do it up with a screwdriver. I think it's split by itself, a couple of reasons. It doesn't look like it's gone all the way through, and look, I reckon these reinforcing strings would be cut clean through. I don't reckon, well, they haven't really fractured, and if it was a knife it would have cut straight through there, through to the rubber on the other side. I think the rubber is just pulled apart. You can actually see daylight through it, so it's definitely split. My little fat fingers in the background there, pushing through. One other thing that concerns me is the amount of stuff that's in there. Check it out, like there's a lot of dirt and grot and grime. Look at that. Now, a couple of guesses where that's coming from. So part of this would have been sucked in because of the split in the hose, but have a look at the inlet manifold. So I've just wiped my finger in there. Have a look how much oil's in there. Sometimes that can be because of a dirty air filter, believe it or not. It can be because of turbo seal, it could be because of EGR valve, PCV valve. The list goes on and on as with regard to what could cause that problem. But for now, the customer wants to sell this vehicle, so we're just going to put the hose on and get it up and running, and then do a forced regen to try and sort out that soot issue. Apparently the DPF is not all that old. He bought this second hand a while ago, against my wishes once again. So this vehicle's a 2010 model. It's only done 76,000 Ks. And it's only been used as a run around in Sydney. Not a good idea for a diesel, guys. Please don't buy diesels if you're going to be in the city. It's a no-no. Alrighty, so we'll chuck that hose back on, do a regen and see what happens. These hoses are actually pretty hard to find. I looked on the net a while ago, couldn't find anything apart from Poland and England. The customer wanted to try for a second-hand one because he wants to sell the car. Couldn't get a hold of one, obviously, because there's not too many of these little diesels around. Genuine only. So there's your part number, not a sponsor. It's a 6M516K863JA. You're looking at about 260 bucks just for that hose. Thank you very much. But hey, if you need it, you need it. These guys got it in overnight from Melbourne, which was fantastic. So I can knock this over before the weekend. So as you can see, I've got the vehicle up and running now with engine malfunction on the dash. That's fairly standard, I'd imagine. Don't be like that, Max. Okie doke. So we'll head out to the road now and we'll do a forced regen on it, and hopefully that will get the whole issue sorted so that he can get it sold so he can buy a decent car. I'm out in the road now. I've just done a scan before I do a forced regen, and it's come up with a third one there. The differential pressure sensor reading is too high, and that's fairly normal when you have a blocked DPF. See if I can go into data analysis and see if we have an accumulation reading. I couldn't see one there the other day, but perhaps I just missed it. Just can't see soot accumulation anywhere. Nah, can't see it. I'll have to take its word for it. But yeah, let's go in and do a forced regen, guys, and see what happens. You can probably hear that. It's finally kicked in. I had to do a DPF reset plus a pressure sensor reset, and it finally kicked in despite what that head temperature is saying. So hopefully it'll work okay. Unfortunately, there's no information there whatsoever that tells me the soot accumulation is coming down, or the pressure sensor, the differential pressure sensor is coming down. No information whatsoever. It's a bit of a pain, but looks like I've got to wait for about 9 odd minutes. Hopefully I can get rid of that check engine light, get rid of the DPF, soot accumulation, and also the turbo underboost. The underboost, of course, is because a lot of the boostage was just being wasted through that split in the hose. So that would bring on the light as a result of that, and that would cause soot accumulation as well. So it's been revving for about 10 minutes at 3 grand, revving its little ringer out. But hopefully it works okay. We'll find out in about 10 seconds If this regeneration has been successful, then I'll do all my resets of everything. Hopefully that'll get this sorted, then I can clear my codes. So it was a failure. Yep, that's what I figured. Alright, so yeah, it's got other issues that I can't really address at this point in time. I'm finding this just a tad weird. We haven't got the check engine light on at present, but it does say engine malfunction. Over here it has our fault codes listed, but notice what happens if I erase that. Now just keep in mind that the engine's not started. Okay, now how is it figuring out that it has a restriction in the DPF if the pressure sensor is not even being activated? That's kind of weird, isn't it? It'd have to have some sort of pressure running through it before it could make a decision on whether it was blocked or not. So, is the pressure sensor okay? Is that a bit dodgy maybe? I don't know. Head under the bonnet and have a look. At the moment we're looking at the pressure differential sensor. I've pulled off the smaller of the hoses, I'm not sure if that's correct or not, and I've got my MIDIVAC attached to that. I've used this MIDIVAC twice in as many days, I guess. Now what I'm going to do is crank up my MIDIVAC and see if that is going to register on my scan tool here. So it should read the same, shouldn't it? See, it says inches of mercury. That's what we're reading over here, if you guys can see that. And so there's 5 inches of mercury, and that should correspond to 5 inches of mercury over there. So let's just crank it up to 5 inches of mercury. That's 5 right there, and it's holding. And what are we seeing over there? Well, it's 1.75 inches according to the scan tool. A little bit different. Let's put on the other hose and see what that reads. So I've just changed over the hose onto the other port of the differential pressure sensor, the bigger of the two. Let's try this on pressure. Let's see if that works. We'll pump it up to 5 psi and see what that registers on the differential pressure sensor. There's 5 psi, and that's reading 2.8 inches of mercury. And is that correct or not? I might have to do a conversion, have a look at a conversion to see if that's correct. So according to my little calculator here, it says that 5 psi should be equivalent to 10 inches of mercury. That's not what we saw, was it? I wonder if this little pressure differential sensor is verschnookered. We need repeatable data, don't we? If I go to 5 inches of mercury, according to my MIDIVAC, I'm reading 1.6 inches of mercury on the scan tool, which is incorrect. If I go up to 10, I'm reading pretty much 3 inches of mercury on the scan tool. If I go up to 15 inches of mercury, I'm getting about 4.5, and that's probably all I'll go at this point. It bottoms out at 5 by the looks of things. So look, that's not right, is it? Not at all. When I go on the pressure side of things, I get the same sort of readings. It's just, yeah, not right. About a week after the customer purchased this particular Ford Focus, the check engine light came on. The second-hand car yard asked him to take it to a specific workshop, which he did. They carried out a diagnostic check and they replaced the air mass meter, they replaced the DPF, and one other component which I think was a swirl valve actuator. It is possible that this is the original problem, I don't know, but before I rule the differential pressure sensor as verschnookered, there's some basic tests that I need to carry out. I'm just having a very brief look around to see what I can find. Good visual is always the important part of diagnostics. If I just zoom in, here's one thing that I've found. Can you see that? There's a cable tie that's been put around. Obviously the connector's not connecting properly, or it's been broken or something along those lines, and someone has put a nice little cable tie on there. Very attractive. I've just had a chat with the customer and he's told me that the original records were in his glove box, so I've had a quick peek at them. This doesn't have what the car yard paid for, of course. This is just their diagnosis, etc. There would have been a separate charge, etc. to the second-hand car yard. Now, some of the things that are interesting are to do with the differential pressure sensor, the range performance. Now, don't believe I've just spoken to the customer and it was only the DPF and the air mass flow meter that was replaced. But we can see them here. They've come back with exactly the same faults as before. This one up here I'm interested in. The pressure sensor is got a performance issue and it's not working correctly. As you can see, I've got my little dressmaking pins in place, and I'm going to start with the basics. 3 wires there. What should they be? Well, one will be a 5-volt reference, one will be an earth, and the other will be the signal wire. Got my negative side of the multimeter hooked onto the battery negative, and here we are on the 5-volt reference, and we're reading 4.99, perfect. And if we go across to the next one, that's most likely our earth. Easiest way we can find out if it is, we just hook it up to our 5-volt reference there. That should give us our 4.99, perfect. I've put my earth back on the negative side of the battery terminal, and if we just go over across to this one over here, we are seeing 0.4 of a volt. Now if I pump up my pressure gauge, we should see a change there, of course, shouldn't we? So as I bring it up, you can see that it's changing. That's 5 psi there, which is 10 inches of mercury, and we're reading about 2.7 volts. This is called a pull down design, because as soon as we remove the connector, it has voltage from the ECU and it remains high, as you can see. When we reconnect it, it should bring the voltage down like that, 0.4. I'll also check for terminal retention and make sure that we have, tight male to female connection on here, so that we don't get a false reading. I still believe that this sensor is faulty. So pricing and speak to the customer. So just want to give you guys an idea of what it's like inside the common rail diesels with all their carbon build up. So if we come over this side, you can see the map sensor. Hang on, just got to go down there a bit. Right, so the map sensor is totally carboned over. It's got grease and oil and all sorts of stuff on it. It's pretty ugly. And if you go further in there, you can see the carbon build up on the side of the walls. And I haven't gone into the inlet manifold yet. So look at that. That's heaps of carbon on there. Sorry, it's not very clear. But yeah, you can see the massive build up of carbon on there. And that's just, that's pretty standard. It's nothing exciting about that. So here's a bit of an example of what it's like inside there with all the carbon build up. Come over here, look at that. Just a massive amount. I'm only just inside the throttle body. Like, I'm not even into the inlet manifold. You can imagine what the valves would be like, etc. With all that carbon built up on there, creating a restriction. Look at it all. How ugly is that? Remember how I said that the original workshop replaced the DPF and a few other odds and sods before they came across what they considered a repair? Now the customer kept the old DPF, and what I've done is had a look at it. It seems okay, and I cleaned it ultrasonically. Unfortunately, the only ultrasonic bath that I could get a hold of is only 30 litres, so it didn't contain the whole thing. You can see the angle where it came down, so I was able to put in for half an hour and then turn it over the other way and clean it the other direction for half an hour. But it's actually quite clean. I'm quite impressed with how it came up. So I don't know if you guys can see in there or not. You can see it's quite clean. This is the front of it. This is where your pipes for your differential pressure sensor come in and out. Can you see down in there at all? So it's quite clean in there too. So I'm going to pop that on and just see if that makes any difference. It can't hurt to put this DPF on. We'll have a look at the other one and see how blocked that is in comparison to this one. When the DPF fails at the back end of it like this, you'll see all the components, all the precious metals are actually melted and destroyed together, and that causes the blockage. But in this particular case, it looks quite clean both ends. I can't quite see daylight through it. Hey, I reckon it's probably, only a little bit blocked in comparison to the other one. Can't hurt to try. Here's the one I've just pulled off. You can clearly see that it's got a lot of blockage and carbon stuff in there. I've seen them worse, but you can certainly see there's a lot of carbon around the edges there. No doubt it's blocked inside. That's the front, of course. Just a bit of an indicator. This is the temperature sensor that I had to pull out. Have a look at the carbon on that. That's going to make it read inaccurate as well, covered in carbon. Carbon attracts heat, and it's going to give an incorrect reading. I had trouble getting it out. I'm going to put some anti-seize on the thread to make it easier for either me or the next person that has to do the same job. So, yep, put the one that I've cleaned in, and let's see how that goes. That's the DPF put back in place, the differential pressure sensor put back in place, the engine cover put back in place, and I am knackered. It's 9:15 at night. I've done enough for tonight. Tomorrow I'll take it for a road test and try and do a forced regen on it. Anyway, tomorrow's a new day, guys, so I'll sign off for tonight and I'll catch you in the morning. Oh, look, I'm back from my road test and I think I've broken the dash. The check engine light is missing. Max, isn't that a good thing? Too right it is. So hopefully you can see it there. No diagnostic trouble codes. Excellent. So some of the things that I did, of course, was a static regeneration there, but also I did a reset of the differential pressure sensor. That's an important thing to do, and the learned values of the DPF. After I did that, the check engine light stayed out. Awesome. After I did the forced regeneration and carried out those resets of both the DPF learned value and the differential pressure sensor values as well, the light stayed out. Then what did I do? I drove it like I stole it. In actual fact, I think part of the problem is that this guy drives like a grandma, for crying out loud, and a lot of these DPFs won't go into regeneration mode unless it's over 2000 RPM. If you sit on 100 kilometers an hour in this particular vehicle, you're at 1800 RPM, not enough to cause a regeneration of the DPF. Is that part of the problem? Well, it certainly wouldn't have helped. So I've taken it for a really long, hard road test to try and get those particulates out of the DPF, even though regeneration has been done, and to try and get the temperatures up and running. One thing to keep in mind after you've done a forced regeneration, you must change the oil and filter. Why? During the forced regeneration process, it adds extra fuel to the mix so that it will increase exhaust temperatures and in fact burn off all those particulates, converting them into carbon dioxide. Two further things I must do to benefit the customer is to change the oil and filter, as I mentioned, but also tell him to, I don't know, speed up? Is that really a recommendation? He goes to Canberra each day for work, and the speed limit there is 110 k's. If he sits at 110 k's, that will bring the RPM above the 2000 range, which in turn will allow the DPF to carry out regeneration processes. He wants to sell this vehicle, but in actual fact, I think he's actually made the situation worse by driving like a grandma. Guys, this has been quite a complex diagnosis and repair, but finally, I hope it's all over. I'll road test it further tomorrow after I've done the oil and filter change to make sure everything is honky-dory. I've got my hands on a launch C reader, and as you can see, it's in kilopascals, which is a little bit easier to read than inches of mercury. Now, at idle, it should be no more than 10 kilopascals. We're at 2 kilopascals, which is awesome. At 2000 RPM, should be no more than 15 kilopascals. So let's just gently bring it up to 2000. So at 2000 RPM, we're looking at about 7 or 8 kilopascals, well below the 15 mark that we're allowed at 2000 RPM. So yeah, this is a fix with the DPF. It's certainly not blocked at all. Awesome. Time for oil and filter change. It's a new day. Oil and filter have been replaced. A decent hard road test has been completed. Scan tool has been hooked up with no fault codes listed, and the check engine light, she is out of here. It's time to hand it back to the customer. Happy days. It is done and dusted. I hope you enjoyed this video, guys, as much as I did working through the diagnostic process and coming up with the solution. If you did enjoy this video but haven't subscribed to the channel yet, please do so. Give it a like, and you're more than welcome to comment down below. And hey, don't forget about that notification bell. You don't want to miss any future videos. So until next time, guys, this is MiracleMAX signing off. I will catch you later.